Here, at least to learn Spring Framework, right? You need basic idea on Java. Java 5, 6, anything would be fine. So now current version is Java 17 and 21 also using, okay? So having Java 8 knowledge is more than enough. Basically, core Java knowledge is required. Okay. From this, what you need to prepare is maybe one front-end technology, maybe like Angular or React. If you don't have that knowledge, at least basic HTML with jQuery, JavaScript also sufficient. Mostly jobs are like front-end and back-end only. If you are a senior guy, like senior developer, you will get opportunity to work on both the layers. Maybe you need to know the front-end framework as well. At least one. So coming to the backend, you will get complete knowledge. Having a Spring Boot knowledge with microservices is sufficient to crack your interviews and even to work on the backend side. In my opinion, backend development is simple than the other areas like a cloud area or front end area. It is very simple because many IDEs are there. They will help us during our coding. So much, so much big community also there. Like if you go to Google and search, you will see so many examples for the same problem. Like that, it will become simple to you once you learn these three layers, right? These three parts, it will be simple to you, to get into backend development. It's not too difficult, but if you are a beginner to it, you need to spend good amount of time to remember what is the concept, what is the need of that concept, and how you can use that solution in your application development. If you can spend good amount of time in the practicals, right? So it will be easy to you. And as I promised, I'll be sharing one separate. You can use this as well. Here you will find all the examples in this link. Spring Framework examples at least, okay? You can see more than 50 plus examples, 58, around 60 examples you can get here. So you can use this link to get the Spring Framework examples. And for Spring Boot, a lot of things we are going to add here. Okay, this is not updated one. And even for Hibernate also, you will be seeing all the Hibernate examples you can download and practice. So that's how I wanted to design this course so that everybody should get the enough knowledge. Yeah. Apart from it, right? So I wanted to start with the MVC. Okay, any course, maybe not in core Java, but apart from it, any other technology which you want to develop your real-time applications. Okay, we follow this architecture. This is the basic architecture that we need to know first. Most of you must aware of it, but once again, let us repeat it. Okay, so let us try to understand what is MVC. Okay, we continuously use this MVC diagram. Using MVC only, I'll explain all the topics so that you will be very much comfortable in MVC application development. Most of the applications, most of the means everything we develop in MVC architecture only. MVC is a architectural pattern. Okay, it is a architectural pattern to implement any application. Any means what kind of applications that you are aware of, maybe standalone. If you are having knowledge on swings, AWT, you guys aware of it, right? JFCs, Java, Faces, something, right? Technology. So using them, we can implement standalone applications. Okay, standalone which runs in a single machine, like your calculator. If you see here, which is running in your own machine. It is not connecting with any internet and servers. So if you need any such softwares, okay, you can implement them by using Sphinx. Okay, this is a Windows machine, so this calculator might be designed in .NET, but even you can implement more beautiful calculator in Java also using Sphinx concept. So such standalone applications like calculators or your shop, let's say if you have some medical store or any shop, gold store, ornaments if you want to sell, or if it is a kirana store, whatever it is, if you want to put your items into that store, and if you want to sell from your application, and if you want to generate bills and all, which is running in a single machine, you can design, and even you can store your result also. For this calculator, whatever calculations we do not save them. But if you want to save something from your front end applications or from your GUI, right, you can use databases also. So you can build such standalone applications by just using the Sphinx AWS, AWT and JFCs. To store your data, maybe you need database. Example, any shop management systems. Or if you want to build something school management, a simple desktop application if you want for your school admin, right? School management system. It will run in single machine. Core Java is sufficient. Core Java with basic database knowledge is sufficient for you to build this standalone. Okay. And beyond standalone, if you want to not only in a single machine, okay, if you want to connect from anywhere without having the code, basically in case of standalone, this application need to deploy in your shop system computer and you need to use there itself. But if you have 100 shops, as a owner, you must visited many shopping malls or retailer stores, right? Like Geo Marts, or here we have many such, right? D Marts. They will have centralized system. All these shops will connect into one single server. So if you want to build such systems, okay, you can choose web application architecture, so that code, whatever business logic you have implemented, maybe by using servlets, JSP's concepts, or struts framework we have, or Spring framework also will help you here. Using any of this, right, you can implement this web application. So how it works means you will be deploying your code into one server and many clients can talk with it. Many client machines. You must aware of it, right? Web application, lot of web applications you are using, like your Facebook, Twitter. Code will be there in a single server and many of you will connect from your browsers. Many client machines, maybe from their web browser, they will connect and they will interact with this server just by entering in web browser URL. This server URL you enter and you will talk to that server application. You will communicate through it. So if you want to place your code in a single machine and if you want to talk, you can go with web application architectures. And beyond web application, if you have huge business logic like banking, transactions, lot of in and outflow if you are getting, and a plain servlets, if you think plain servlet struts, if they are not sufficient to handle it, or a single server if it is not sufficient to handle it, we break again the same application as a distributed application. And we deploy code also in many servers. In distributed application, what we do, here many clients are interacting with one server. In distributed, we will have multiple servers, many servers, n number of servers we will have, for the many clients. Why this many servers? Because your logic is very huge. It need to handle so many requests which is coming from the clients, especially like banking applications. Example here, we can say in real time banking applications or stock market will have lot of data flow for each second. So there they should not miss even a single transaction while you are doing fund transaction of 10 lakh rupees or 1 crore rupees to one account to another account. If it get failed, no, it should not. You will see lot of loss if something happened, and if you get zero balance and other party also if it is not received the amount. So especially such huge transactions based applications we will architect them in a distributed manner. Sometimes you may see failure in Facebook while uploading your post or while entering your comments. It's okay. That is not having any cost impact to you. You are not bearing any loss. There is no loss even if your comment or if your post if you lost. So that's why they don't care. I mean, they also have multiple servers, but such applications will not care, okay? Because you will not seeing any direct loss. But when it comes to banking applications or stock market applications, every second is precious. That much robust applications we need to build. So we use generally distributed architectures for them. And a lot of failovers means if one is down, another will go up and serve the purpose. So even in distributed applications also, right? Microservices are advanced. Same applications, not only banking, even your web applications also you can design in microservices. Basically, they will run on REST principles, only REST protocol they mostly use. Otherwise, for security purpose, so protocols or RPC protocols also they can use. We will talk about it later, but this is somewhat related to distributed architecture, okay? It is like advanced distributed architecture. We can say in advanced distributed architecture. Using microservices, you can build any applications. You can, okay? Any applications. Mostly for e-commerce applications, they are, really blessing. Beautiful to design e-commerce applications on microservices. E-com or anything, no limitations, okay? Anything. Nowadays, every application designing in microservices only. You will understand slowly, okay? Why they all moving towards it instead of choosing a single web application. You will realize end of the session you will realize, or you can suggest even to your team, or if you are like a senior guy or you are a leader, you may suggest them to go with this architecture. Of course, everybody following it, apart from old applications which are still running in single code or monolithic, we can say. So e-commerce or banking, whatever you choose, okay? Anything. To design any application, right? You know what kind of applications we can able to build. Okay. Here, coming to technologies, right? Here you can build this distributed by using EJBs. Of course, Springs also can help you, and you can use. Yeah, earlier we used to have them, EJBs and Spring. Now here to implement microservices, we completely depend on Spring Boot. Using Spring Boot, we'll implement them. Simple to implement by using Spring Boot. Along with it, you must have database. Always database will be there to support us to save the data. To persist our data, somewhere we need to record them, right? So that is what database is. Database will be everywhere for every application. Okay. So to design any application, when you choose for your particular requirement, I want to develop a school management system, or I want to develop a small web application, or a distributed application, or a microservice based application, whatever you choose. We start with a basic foundation or basic rule or basic architecture. If you want to construct a standalone house or a villa, or if you want to construct an apartment or a high rise, you will be having same basic principle, right? We will put the foundation. First, we will put the foundation strong and we build anything on top of it. Okay. That is what MVC is. Okay. MVC is a basic architecture pattern that you have to use to maintain your code clean and maintainable. To maintain your code clean and maintainable. It can be a standalone, or it can be a web application or a distributed application. Why we choose this MVC? You know, skilled guys may say, I know, I don't follow, I'll write everything together. Yes, they can do, but it will be not be maintainable code. If somebody see that code, they can't understand it, they can't maintain it. That means if you put a foundation and if you ask some other contract to build a home, he'll say, no, it is not possible for me because I didn't understand what kind of foundation he did. Getting right? So we mostly follow MVC architecture. Okay. What MVC means? MVC is an architectural pattern. It's not a technology. It's an architectural pattern. It's a pattern, just a rule. That too, it's not a strict rule. It is a recommended rule. Okay. So it's an architectural pattern considering of three parts: model, view, controller. It will be having three layers or three parts: model, view, controller. So what each part will do, what model will do, what view, and what controllers will do. Models, basically they will handle all the business plus database logic. Business logic and database logic. We will say it model layer. Okay. Business logic, which means, let's say if you are doing a fund transfer, you have 10,000 in your account and you are doing phone pay, 1,000 rupees to my account. Then there should be some calculation required, right? 10,000 minus 1,000. This minus calculation, and again your account need to be updated. Once fund transferred to me successfully, your account will be updated with 9,000. So this basic calculation will be happened, right? So we call it as business logic. And once after transaction successful, you will keep the remaining balance in your database, in your account, 9,000. That database logic we perform here. So business calculation and the database update operations or insert operations we handle here in the model layer. What about view? From wherever you are accessing your bank account to add some other participant, or from wherever you are doing fund transfers like UPIs, you will be having view, right? Nice views. There you go and you enter number and you do transfers. Such views, right, will be designed maybe by using HTML or maybe Android UIs you might see, mobile UI, Android or iPhone, or you may see React or Angular UIs. There are many technologies to design views. So the presentation part, whichever holds the presentation logic, end user will interact or end user will show interest on view only. He don't know about what kind of logic, business logic, database logic you implemented. He only aware of view. As a end user, if you are using a phone pay or Google Pay, or if you are using some other application, you go to your application and you show interest on UI only. You will not think about what happening in the background. So the beautiful views, or what we can say, of end user front ends we design here in the view layer, so that they will interact to your backend code. Okay, so model will hold the business logic, database logic, view will hold the presentation logic, and controller is a mediator basically between your business and view. Let me show you it through a drawing. Okay, you all aware, you must feel boring, but you should listen. Okay, because every time we go with MVC architecture only, and you need to realize why we should use MVC. Why not? If we don't use MVC, what will happen? We should realize it. Everybody knows MVC, but what if I don't use MVC? Also, we need to realize. Yeah, so here as part of MVC, you can see 3 layers. Okay, I'll start with view layer, controller. So the middle one is controller, and the last part is model. So basically, end user interest is front end only. Here is the end user. This is you. For you as an end user, you interact with only front end. You put your request here on the front end, and the data need to flow. Once you submit this view, or once you do the transaction, or once you say, pay or something, it will ask you passwords. Once you do that, the calls will go to backend controller layer. So the controller responsibility is it need to exchange information from view to model, model to view. This is the backend part. Controller is the backend part, which is the first point of contact. If somebody enters into your apartment, they will reach out to the watchman. So he is the first point of contact. He will ask where you are going, which apartment or which floor, which flat you want to visit. So he will check whether that request is proper request or not, and he will allow. Otherwise, he will not allow. So such a responsibility controller will take. Not only basic security, other activities also it will do. So once controller receives the data from view, it will send to your model. All the actual business logic and database operations we handle here. So again, we can classify, or we can divide this model into 2 parts. Going forward, I'll make it again 3 parts. Okay, model will have business logic, and the database logic. I'll call it as a repository. Okay, repository. Or since nowadays we started using it, earlier we used to call it as DAO. Okay, data access object, but let's call it as a repository. Repository layer, business logic. Repository means whichever is interacting with your database. So here front end will showcase all the presentation part, whatever mobile number you enter, and the amounts and the contacts and pay, whatever interactions user need to do, right? User will interact with view only. Once you give sufficient input, excuse me, once you give sufficient input, the request will be taken to controller. From here to here, the request will go, and controller will send the same data to your model. Especially the data first will go to the business logic, and all the business operations will be handled here. Then it go to repository. Here internal interactions will happen this way. The data will go to business and business will give it to repository. Repository will do all your CRUD operations here. You must aware, right? All the create, retrieve, update, delete operations. All CRUD operations will be handled here. Fine. Which means it will interact with your database. Directly it will interact with your database. We know what database contains. It will have tables, data, views, procedures, functions. It's all depends on the database. Maybe it is a SQL database or no SQL database. Again, they have many types. Let it park aside. So here, if you try to understand model view controller, view contains the presentation, which helps to user to interact, and controller will do the middleman job. So read data from view and send it to model, and again finally it will give response. So the read, send, response, read, send, response. This operations it will do here. It will read data which is coming from your view, and it will send the data to business, and it will give response back to views. That is the responsibility of your controller. And the model will handle most business logic, all the algorithms or all the plus minus operations, whatever you do, multiplications, interest calculations, all that calculations will be happened here. Finally, database logics we write here. Why we need to have this many layers? If you are a skilled, you might ask it. Yeah. So when we divide everything logically, it will be simple to us to maintain it in future. Maintainability will become easy to us. Consider here you have database logic and here you have business logic. Instead of separating them, if I club both of them together, in future, if I wanted to change a business logic, it might impact your database logic as well. And there is no reusability also. If I club this code together, if another class needs the same CRUD operations, they also again need to write the same logic. So the code also will become, in many places, it will be duplicate. So instead of reusing it, we are trying to duplicating it. If I make it a separate layer, what I can do, my business class can use this CRUD operations. If another business class also needs same CRUD, they can also use it. And coming to business, same thing. If I maintain a separate business layer for each functionality, it is easy to maintain. For adding, when it comes to the banking application especially, we add pays and we do transfers, we do recharges. So each is having a different business logic. For doing recharges, you may have separate business class will handle all the logic behind the recharge operations. And if you want to add payees, the payee related logic will be handled by one business. And if you want to do fund transactions, which is having the great transactions logic, it might have in a separate business. So that in future, if you want to maintain or if you want to change something related particular to that business, you can go and edit that class and you can do the changes. Same way, controller and the view. As I separated them, maintenance will become easy. If I don't separate them and if I club everything together, maintenance will become difficult and no reusability. What are the benefits of it? What are the benefits of it is clear logical separation. And maintainability. Anything else? easy to maintain. Easy to maintain, and it is flexible for upgradations. Updates. Generally, we used to update our apps, we used to update our missions always, right? So your application also should be flexible for updates. So as it is clearly logically separated, it is flexible to you to do the updates. And reusable also. Reusability. See, so many benefits. That's why people say follow MVC architecture for any application. You will get a lot of benefits. Okay, you will get a lot of benefits. So you need to follow this architecture. Try to see this topic, okay? Object creation at runtime. Okay, I'll recommend everyone to see this example. Once again, I'll ping this link to you. Okay, first example. This is the one, basic object creation at runtime. Many of might aware, but still go through it. So here you will see object creation, basic core Java concept only, but it is very important. If you understand this, you will understand whole Spring. A small topic, one single line code you will see there, 1 or 2 lines code. How you will create object during runtime by using class dot for name. We used it many times in JDBC. Not only by using new keyword, by using class dot for name, also we can create object. That is not a simple class. That class given us, that simple class, that is like a, looks like a simple code, but that made to create many frameworks to create object at runtime. If you don't have this logic, if Java doesn't allow you to put this logic, there is no Spring framework or Struts or Hibernate framework. This made us to prepare frameworks on top of Java. This simple 2 lines code. Okay, just go through this example. I'll explain you more detailed about it. Okay, how it is helpful. Even if you want to design your small frameworks also, it will help to you.